So another way to think about this, Marcus, is that if you're taking derivative of x squared with respect to x, do it the way you've been doing it the whole time in this class. If this is different, then you have to pay attention, all right? So derivative of x squared with respect to x is going to be 2x. Plus, now Marcus, I'm going to keep you on the hot spot here. We've got to take the derivative of x what, y?
X times y.
And how do we take derivatives of products? Okay, so we have to apply a product rule here. Everyone see that? There is a product, and we must apply a rule. We didn't need it here. We only needed the little power rule, chain rule. Now, the product rule says, I'm going to take, just go ahead and tell me, Marcus, I'm going to take derivative of x times plus times x, right? That's what we're going to do? Okay, so what is the derivative of x, Marcus, with respect to x? 1. Okay, 1 times y, okay, plus, now, Marcus, very important. What is the derivative of y with respect to x? dy dx. There it is. There it is. That's the piece we wanted to appear. dy dx. And are we done, Marcus? Times x. Perfect. Excellent. Now I'm going to highlight this. This piece right here, right, is the product rule being applied to that piece right there, right? We're not done, but Marcus is done. Thank you, Marcus. David M. I'm going to give you the day off, David, because you weren't here last time, and without chain rule, I think you got some stuff to do this weekend. Jackson, you're up.
If you want, I can give it a shot.
Do you want to? I'm not going to. Yeah. You just kind of looked at me like, okay. So okay, we'll go. I'll let you go with this one. So we're moving on. Minus, right? And you got to take derivative of y squared. So minus. What is the derivative of y squared? Everyone, listen to the way I'm saying this to David. David, what is the derivative of y squared with respect to x? So, what do you think?
Would be. Is there an element of dy over dx?
There will be, yes. But you got to get to it first. So if I ask you to take derivative of anything squared, the first thing you're going to do is what? Exponent comes out, right? So 2, right? 2. Then what? Y to what power? 1, right? So I'm not going to write it. And then now you go inside and take derivative of what's in here, which is?
dy over dx.
There you go, dy dx. And that's it. You're done. You've taken the derivative of y squared. So the derivative of y squared is not 2y. Now when you take derivative with respect to x, when you take derivative of that with respect to x, it's 2y dy dx. Are we done with the left side? Have we taken derivative of this, this, and this? Yes? Okay, move to the other side. Equals 0. All right. Now we have an equation that has dy dx in it. So here's our dy dx right here and right here. Right there, it's attached to that, right? Those are the two terms, right, that have dy dx in them. So the way we're going to solve for dy dx is anything that doesn't have dy dx is going to go to the other side of the equation. So I'm just going to keep dy dx times x minus 2y dy dx over here. And then on the other side, I'm going to move the 2x over, and that's just a y, right? So I move 2x and y to the right side, which makes them both negative. Now, why is it that I isolated the dy dx terms? Why do you think I got those alone? So I can factor it out. So I can pull out a dy dx, and I'll be left with x minus 2y equals negative 2x minus y. And what's going to be my last step? Divide, right? This is this times this, so I'm going to divide that whole thing out on this side. And I have found it. You have found it. We have found it together. Okay? There we go. Now, if you want to know the slope of the tangent line at some arbitrary point on this curve, you first have to give me a point on that curve. That's important. If I'm going to talk about this, slope of tangent line, you must provide me an x and a y that live on this curve. So you can't just like pick some arbitrary x and y. Like I can't pick the point 0, 0, okay? I can't pick 0, 0 because 0, 0 doesn't live here, because if you plug in 0, 0, it's not true. So you'd have to find something that would work. Like I think the point 2, 0 works, right? 2 for x, 0 for y would make that true, wouldn't it? So that point lives on the curve. If I want to know what the slope of the tangent line is here, I just plug it into this, and that'll give me the slope. Make sense? Let's leave the problem up. We only have a few more minutes. I'm going to change the problem. Find what? Dx dy. This time I want you to treat what like the independent variable. I want you to treat the y like an independent variable this time. So when I come in here, I'm going to take the derivative on both sides, but I'm going to say d over dy over here, x squared plus xy minus y squared equals d dy 4. Did I tell you all that story about the interval 0, 1? No? Okay, never mind.
Does it go like with the stars?
The stars, yeah. About the club, going out to the club, the girl I met? No? Okay, all right. We'll have to get back to that story another time. All right. I'll try and tell it if I have a little time here, because we're just going to set this one up. So this time we're treating y like the independent variable. So who wants to, Jackson, you were up next, right? Yeah. Okay, so Jackson, with what we've talked about today, now when we take derivative of this, what's it going to be?
Is it going to be dx over dy?
After you do what first, though?
We bring the 2 up.
Okay, so 2x to the first times dx dy. See, this time it's not 1. And the reason not 1 is because these variables don't match. So when you do the 2 coming out and then x to the first power, when you go and take derivative of x with respect to y, it's not 1. Got it? Plus, okay, now we still have to do the product rule, don't we? Okay, so when we do the product rule here, we have to take derivative of this one times this one plus derivative of this one times this one. But we're differentiating now with respect to y. So what's the derivative of this one with respect to y? Dx dy. Now times what? Times y. And then plus, now the derivative of y with respect to y, which is 1 this time, because it's the same variable, dy dy. Times x, finishing product rule. Minus, what's derivative of y squared with respect to y? 2y. And then it would be again there dy dy, but that's 1. So I don't need it. And the other side's 0. So I'll tell you this story real quick. I told you all the story about the numbers between 0 and 1?
Yeah.
I did? But I didn't tell you the story that went with that? No. Okay. I'll make it quick. Y'all can start packing up. I want you to start. And I'll turn.